Good morning again. So we shall continue our discussion on arrays and pointers. Uh, so let's write some. Today specifically we will focus on what are the intricacies or challenges involved in passing arrays to as parameters as arguments to functions. So let's write a program. Let's call it, let's say, yeah, summary.c, and let me keep my code window here. So let's say, so now we would like to have one function to initialize array. And then we would like to write one more function which adds up the elements in the array. All right. So let's call that parameter. So one parameter is of course the array parameter, and so in order to, let's say we want to initialize a simple we want to use a simple strategy that a of I should be initialized to I. This is our strategy. Now let's say, for the sake of simplicity, I star, to make it slightly more interesting. Let's say we want to initialize a of I to I star I. And then here in the main, we have an array. Let's say we declare an array n1 of size, some size. Okay, let's say some size 100. Or let's make it simple, maybe 10. So we would like to call this array init underscore array, and we want to pass n1 as parameter. And let's say we have one more helper function which prints the contents of the array. So the first question for you is how do we go about writing the function init underscore array? How do we go about writing the function? Are there any challenges in writing the function init underscore array? It's a simple strategy. So it's a simple loop, but the primary thing is without knowing the size of the array, we will not be able to. So we want to use something like, like for int I is equal to 0, I less than or equal to size. The size is the size of the array. Let's call it as array underscore size plus I. A of I is equal to I star. So right now the problem is, as you can see, the in init underscore array, so that array underscore size variable is undefined. But without knowing the size of the array, we will not be able to write this loop. So we have to pass one more parameter int array underscore size. And so here, then you can see there is an error now here because it's saying too few arguments in the function call. So now we are good. So now there are no errors. They're all good. Are you with me here? That when we are passing an array as a parameter to a function, we need to pass the array size also as a parameter, without which it is not possible no, for the function to carry out its computation. So couple of things here. So let's say magically, so let's say magically, or like for example from the domain, or uh, so let me, instead of saying dumb, I will say in init array uh, not safe. We can write no not safe init array. So this is not quite a good piece of code, uh, because we are assuming, so here we are assuming, if I replace this with 100, we are assuming that the size of the array is all the time 100. So there is a problem. Yeah, okay. Size is 10, yeah, size is 10, not 100. Good. So there are a few questions. I will take those questions later. So primarily, there are some ideas I would like you to understand. So let's focus on them. So the second function on line 20, it is not really a safe way of initializing the array, because we are assuming the size of the array to be fixed. So this is not a good way. So now let's look at the print array. So print array also is the same thing. So this for print array also we have to pass int array underscore size as parameter, and then so here we have to print, we say printf %d equal to %d slash n I comma. So this is how we print the array. So now let's do the init array and print array and see what happens. So you can see that the array elements are successfully initialized, and it is yeah, a of 9 contains 9 times 9, which is 81. So it's all good. In the last class, we have seen that this array access, no, a of I, it gets translated into star of a plus I is equal to I star I. So what happens is the C compiler, it doesn't check whether, like the size of the array, like for example, in your mind, no, the size of the array is 10, but let's say the size of the array is actually 10, but instead in the earlier case, I am passing 100. So if you just end up passing 100, the compiler, I guess, wouldn't complain, and you go ahead and this loop will go ahead and execute. All right, so let's see. So the point I'm trying to make here is, let's say if I have init underscore array is equal to 100 and 100, what do you think will happen? Do you think the compiler will compile, will say, will give an error? So the size of the array is 10, but we are passing 100 as parameter here. What will happen? So what is the program? So see, the compiler is not uh, so the compiler is compiled, so there is no error. And let's see what happens if you run the program. Ha, you see that there is something called a stack smashing detected, and aborted core dump, and some weird errors are coming. But you can see that like we have overrun uh, what is you're able to successfully this unit array function, it is able to successfully execute. There is no uh, problem. So when you write your programs, it is your duty to see that things are all working well. That, I mean, you don't give a, that you don't overshoot the array index or the array size. It is your job as a programmer uh, to see that you don't make such errors. So here, if you recall our discussion on activation records, etc. So when main, so here, let's say initially main is there. So this is main. So main has an activation record. In the activation record of main, the memory for the local array n1 is allocated. So memory for n1 is allocated here. And from main, we are, and when main calls, init underscore array, so what happens is this is how the stack will now look like. This is the activation record for main, ar underscore main, and the memory for n1 array is present here. Uh, so yeah, and then so when you are calling, and then so the activation record for init array will be present here. So this is the activation record for init array. This is the AR for init array. So in the init array, you start no uh, you you are when you overshoot the size of the array, you may end up uh, overwriting the stack, which you are not allowed to do. So yeah, so you have to be careful when you are working with arrays, because any kind of errors that you make, it can it can lead to disturbing the state of the stack, and that can lead to segmentation fault and other errors in your program. It is never possible for you to modify the memory of other process. No. Segmentation fault means it's some kind of error. So for the time being, don't worry about it. So, but all I want you to tell is, when you try to overshoot, try to write beyond the array bounds, you may not get any compilation errors, but at runtime you may end up getting weird errors, and which would be hard to debug. So there is a question from Gaurav. So will we get this error if we give anything greater than let's say if it is 11, let's say the size of it is let's see what happens. So even with 11 also, it is saying that there is a stack smashing happening. So I don't know exactly how the compiler, something interesting is happening. Uh, let's do one thing. Void pre-init underscore array. Ah. Hey, don't worry about so much about stack smashing. All I want you to understand is if you don't, if you try to overwrite out of bounds, things can go bad for you. And just want to be careful about it. Okay. It is happening after, yeah. So something, anyway, I don't want to get into this stack smashing stuff, and many of you will get lost. So, so what I will do is I will hold on to, I will not answer any questions related to stack smashing in the interest of um everyone or most of the students in the class. But what I would like you to understand here is, when you pass this array size and when you are trying to access the elements of an array, and if you end up accessing out of bounds array, uh, you have to be careful. You have to be careful in the sense you will get into some errors, runtime errors. You don't get any compilation errors, but you'll get into runtime errors. Are you all with me here? You don't get compilation errors. Just because there is no compilation error doesn't mean your program doesn't have any bugs in it. There could be some runtime errors and you could get into trouble. Are you all with me here? To this extent, to the extent of discussion that is happening, I hope you're all with me. Let me remove this. Yeah, segmentation fault is runtime error. That's true. Segmentation fault can be, it's a runtime. So now let's remove this not safe init function also. So now let's say we want to work with 2D arrays also. Okay. So 2D arrays void init. So now let's call this as init underscore 1D array print 1D array. So obviously when we are working with 2D arrays, we need to know the row length and column length. So let's say m is the number of rows and n is the number of columns, or maybe let me use number of rows, number of columns. And then, so how do we initialize this? Let's look at this. Control V, format document. So we have to use nested loops, exactly. Number of rows, let's say for j is equal to 0. Nice. So we are all good here. Is there any error? I'm still seeing some error. So here you can see, so this looks like a reasonable thing to do. And but then if the compiler is not permitting us to compile this program, let's compile this program and see what happens. So if we compile this program, implicit declaration of, oh, okay. So you need 1D array, 1D array. So anyway, it's not for the time being. So when we try to compile this program, so there is an error which says that on line 24, so here this is the error, precise error, that array type has incomplete element type. So and then there is a second note says declaration of A as multi-dimensional array must have bounds for all dimensions except the first. I'm not able to hear. Let me just give me a moment. Okay, so do you understand the problem here? There are a couple of errors you can note. That there is a note here which says declaration of A as multi-dimensional array must have bounds for all dimensions except the first. So here, what when we are passing multi-dimensional arrays as parameters, let's say int n2 of 10. Yeah, let's say 5 by 10. So the init underscore 2D, so it should be, it says that the second parameter, all the dimensions except the first parameter has to be passed. So now the compilation will go through. If I do the compilation, there is no error. So when we are passing multi-dimensional arrays, in the parameter declaration, we have to pass all the parameters except all the size of all the dimensions except the first dimension. So here now we can call init underscore. So there are few questions that I'm seeing on the chat box. I want you to hold for some time. I will take your questions, 5 and 10. So actually, yeah, so here this is what we are trying. So we are passing the number of rows, number of columns, and we are passing n2. So now the init will happen. So now let's see how we can print this. So let's see what is happening there. So int yeah, so here let me not print it this way. Print %d/t and a of ij. So now let's see how the program. So we are initializing the array and we are printing it also. Yeah. So this is how. So we are able to successfully. So a of I comma j entry is initialized with I plus j. So this is the printing of the matrix in the 2D form. So some of you, so now, so already I can see the discussion. So when we pass, see when in the case of 1D array, in the case of 1D array, in order to access, in order to, let me maybe use a, so a of I gets translated to a plus I, and a star of, and then in the last class we have seen in terms of raw addresses, this is equal to a plus 4 star I. Are you with me on what is there on line 20? We have discussed this in the last class. I will clarify the questions you have, but I want you to recap and see where we are. Let's go slow. Okay. So just those of you, so some, if you are getting confused by looking at the chat box, so you can refrain from watching the chat box or selectively ignore things. Uh, so, but just follow the thought process that I am building up here. Hey, can you hear me, guys? There is a network error in the institute, and sorry. Uh, network problem. Okay, so now we are back. So we were thinking about this thing. So when there is a, so this is the question that so that is asked in the exam. So let's say uh, so there are so let's say there are m columns and n minus 1 rows, and so if you see if you access the element a of 0 j, then that means so it is like a plus j star. And like let's say if it's an integer, if the entries are integers, then in terms of raw entries it gets translated into uh, a plus j, a plus 4 star j. Are you with me here? What happens if you access the first row? So similarly, so but if you access a of ij, if you access a of ij, uh, yeah, RHS, this is in terms of bytes. That's true. So a of ij, so a of ij means you have to access the ith row. You have to access the ith row. So before ith row, there are I rows, because that. So before ith row, so there are I rows, that is 0 to I minus 1, 0 to I minus 1. So if you see the base address, so there are I rows, and so that is a plus m star I plus the jth element plus j. So this is how the address gets calculated. But this is not in terms of bytes. Are you with me on this one particular thing? Like there are, in the 0th row, there are m elements. In the first row, there are m elements. In the second row, there are m elements. So when we are in the ith row, so we have to skip no, m star I elements. And in the ith row, we have to add j. And when we want to translate it into raw bytes, so we have to multiply all this offset with suitable offset, that is 4 maybe. Like, or maybe we may have to subtract 1 from m star I plus j minus 1 or something. So anyways, the point here is in order to compute the address of the element aij, we need to know this thing m. We need to know m. That is the size of the number of columns is required. Are you with me here? In this expression, a plus m star I plus j, I is available. So when you access in this code, when you access I plus j, a of ij, I is there, a is there, j is there, a is there, but what is missing is m, which is the dimensionality of the number of elements in the second dimension, that is the number of columns. No, no, A is not an array pointer to n. No, no, not at all. So no, A is not a pointer to pointers. A is the 2D view. It is just a view for us, but in terms of memory, so if you see, don't get confused, guys. So the 2D array, it gets mapped to a linear section in the memory. So this is the memory. So what happens is, let's say the memory for array A, like for example, A of 0 to A of 0, let's say the first, this is the first row. This is row 0 is laid out linearly, and after that row 1 is laid out linearly, and after that row 2 is laid out linearly, and array A, it points to the base address. It's not a pointer to pointers. Are you with me here? And the length of each section, is m, where m is the number of the size of the row or the number of columns. So in order to, if you are accessing something in this section, you have to skip 2 sections, and then you have to go here. And unless the second parameter 10 is passed here, you don't know how many sections you have to skip. You don't know how many sections you have to skip. I think this could be the reason why C requires us to uh, pass the dimensionality of no the number of elements in each of the dimensions except for the first dimension. No, for the compiler, in order to calculate the address of Aij, it needs to know the number of columns. Without knowing the number of columns, how will the compiler know? Like for example, this Aij, it gets mapped to this. It gets mapped to this. Aij, it gets mapped to this. But in order to do this mapping, please pay attention. This Aij, it is getting mapped to this. That is A plus M star I plus J. But no, not only the number of dimensions, the elements in each dimension. The number of dimensions the compiler will know if we keep 2 square brackets. But we also need to know how many elements are there. That is the number of columns are there. Before we think about alternate strategies, guys, I want you to understand whether you are all with me on the basic stuff. You may come up with workarounds. What I want you to point is this Aij axis, it gets mapped to M star J plus I. So here it gets mapped to A plus 4 star, no, A plus I. Here it gets mapped to A plus M star J plus I, where M is the number of columns. So if you don't know M, here M is nothing but 10. If you don't know M, the compiler doesn't know how to calculate the memory location associated with Aij. Yes, Pramod, you got it right. Yeah. Oh, no, it is M star, sorry, M star I plus. Thank you. I through J, yeah. So because of this, reason, so we need to pass that parameter M. So if we give a 3D array, the first element, the number of elements, the first dimension, we can leave it as it is, but the second dimension, we need to specify. Let's say if it's a 3D array, it will be something like this. Well, this is how, I hope, I hope everyone is with me so far. Are there any questions before we move on? Again, you can send a private message to me if you're not sure. Okay, let's get going. This is a requirement in C89. You know, there are C89 is one standard, and C99 is the latest standard. In the C99, we can, so the problem with this particular approach is the kind of arrays that we can pass as parameters as constraint. Like for example, for init underscore 2D, the dimensions, the whatever the data structure that we are passing, no, this 10 is fixed. So we are kind of constrained. We are constrained. So this is a problem. This is not a good idea. So this is a constrained thing. This is a problem. It puts a constraint on the kind of 2D arrays that we can pass as parameters to this init underscore 2D function. Yeah, we can use a macro that will, but still the constraint remains the same, in the sense you can only pass arrays of certain dimensionality to this init function. So in C89, C99, that is the latest C standard. It seems there is a change. There is a new way to do it. Init underscore, for the sake of making it clear, I say C99 standard. So it seems we can use something like number of rows, number of calls as the parameter. But if you do that, it seems again you can see that there is a problem. It is complaining a number of rows is undefined. So it looks like we have to someone is talking. So are you all with me here on this is C99. This is in C99. It is possible for us to pass variable length arrays as parameters to a function by using this particular approach, where you pass the number of rows, number of calls, and then you have this. It is possible here. So using pointers is yet another approach of doing this. That's true. There's an alternate way of doing it, that is using pointers. So now let's see, let's do an init underscore. So now with this, what we can do is, let's say I have two kinds of arrays, n1, n2, n3. So this is 10 by 5. So this is and let's say we have another print version also. I'm just thinking one more one question I want to ask. I write this code. So do you think writing this code before you is waste of time, or I should write this code before and come to the class? Any input on this? I'm right before. So here, good. So this is, I'm just thinking, wondering whether it's waste of time or for you, or that's okay. So anyway, so let's see. So it's good to. So now we have init 2D array underscore C99 and underscore C99 print So you can see, oh no, this is also init. Yeah. So init we have, and then we have this print. Yeah. So order of arguments is different. Oh, okay. Order of arguments is different. Thank you, Mihir. Let's see what the compiler says. If I compile, it's not. This is not showing problem. Let's see the compiler if it gives any problem. Yeah. Yes. It is making. So we are. There are lots of errors because the order in which we are passing the arguments are. Awesome. See, this is the first matrix. I didn't print any separator between them, but this is the first matrix and this is the second matrix. So now if you see, with this, so this, when we just compile it by standard, it uses C99. But if I say std is equal to C89 and compile it, then it gives all errors. Oh, first of all, for loop initialization is not allowed, and yeah. So C++ comments and lots of things. Okay. So anyway, so in C89 standard, this kind of init is not allowed. Like init has to be outside. That int I is not allowed. So so we are halfway through the course. Like there are two standards are there: C89 and C99. C99 is the latest standard, and C89 is the old standard. So like, for example, so the one complaint it is making is in C89, this kind of thing is not allowed. I cannot use int I, so I have to use int I here. So similarly, what was the flag for minus std equal to C? Yeah, you can see. If you don't use anything, by default, it is C99. No, it's C99 is a default. So yeah. So anyway, so what I'm trying to tell is this particular variable length arguments, variable length arrays, it is not allowed in C89 standard. So that's what I tried to show you. But anyway, in order to show that, I have to make a lot of code changes. I'm not going to do that now. Are you all with me here so far? So now I want you to write one program. So one simple thing. So we have initialized 1D array, 2D array, and all. So let's say let's say we want to, yeah. So what's the question, Karthik? So let's say I want to transpose a function, transpose matrix. So in order to transpose matrix, I just want to use the same signature. So what is the code for transpose? So it's very simple code. Yeah, so instead here, we would like to use swap a of I, a of j with a of j, a of I. So what do you think if you get it, if you do the whole thing? Do you think, where is the swap function for us? let's say we want to do an in place swap. We have to do not in place transpose. We don't want to create a new matrix. The same matrix we want to transpose, in place transpose. So this is not going to work. So how many of you realize this, that this may not quite work? So swap int star a, int star b. Let me use where is my swap.c? Yeah, this is what I would like to do. So here, does this work? So if I send a swap of aij, aji, does it work? One more interesting thing, that swap, yeah, so there are few, awesome. So there are three important things. Number one, no, when we are doing swap, okay. So Pratyaksh has this very nice observation, that if we don't work with a square matrix, so if we start with a matrix of dimension 3 by 4, and when we do a transpose, it becomes 4 by 3. So the dimensionality of the matrix will change, and so things may not quite work out well. So there is a problem here. So I want you to think about it. So let's say, but if you work with square matrices, okay, if you work with square matrices, then we are good, right? So are we good if you work with square matrices? No, why is it not a problem? Yeah, so let's say if it's a square matrix, then what do we do? So how do we solve this problem? So there is a transpose for int I is equal to j. So what should I do for how should I change my loop bounds? I plus 1. Huh? I'm following you guys and see what happens. Does this make sense? Does it work? Is it going to work? Will this work? Yeah, so that there is a last thing. So we have to pass the address of the elements here. Are you all good now so far? Let's compile and see what happens. So yeah, let me make it int and 4 5 5. So here's, look at the code. So here what is happening, I'll just make it easy for you. So this is the original matrix, printf after transpose /n. So transpose a 5 comma 5 comma n4. Okay, I don't need this thing. Is this working? It's a dumb example. So for all the effort that we have put in, we took a symmetric matrix and we tried to find a transpose, and it turned out to be the same. Okay, good joke. Uh, so let's make it, yeah, so let's make it instead of, yeah, maybe, yeah, j minus I, maybe, yeah, good. Good one, man. Yeah. So now, awesome. That's a very good suggestion from Abhinav, actually. Thank you, Abhinav. It's a very good suggestion. So in the before we did the transpose, um, you have all the positive numbers above the diagonal and negative numbers below the diagonal. After we did the transpose, uh, we have no negative numbers above and positive numbers below. So it's nice, nice. Okay, good. Uh, so this is pretty much about how to work with multidimensional arrays. How do we pass them as parameters and things like that. So time now is 11:30. So yeah, so I thought I'll show you dynamic memory allocation also, if or otherwise we can take it up in a next class. Uh, okay, next class, next. Okay, I think maybe we'll take a pause because some of you are not have something else to do. Um we'll take up. Okay, yeah. Let's let us all be on the same page. So it's okay. So, anyways, I think the class came to a logical conclusion, and it's a nice place to stop also. So, in the next class, we will look at dynamic memory allocation, and we will take it up. Let's stop recording, and happy Diwali.